How are you? How are you? So, I wanted to go eat dinner, but I said even 1 hour. Fucking 1 hour makes huge difference. So, yeah, I don't know, like. So I said I'm gonna work an hour and then eat dinner. Because after dinner, like the odds of working, you get into your phone and then who knows, maybe I wanna go to the gym. Haven't worked that long time. I think this app that Sam is building is super important. Keep on. I need to keep it on my phone. And so that's it. Stressful days. Honestly, this 1 hour and another 1 hour, maybe 15 minutes. The other one is not even 1 hour, 15 minutes. Just really kills all the stress. Actually, that's the key. The key I found. Whenever I get stressed, the only thing that solves the issue is working. Honestly, it's amazing. You just work. Shut your mouth and work, and the stuff gets better. Honestly, it gets better. What the fuck? Why don't I get connected to MIT? These are signals. These are signals for me to finish my PhD ASAP. They don't let me connect to. Alright. Okay, just no internet. So I don't know what is. It is good. Honestly, I have this feature. I have this feature that whenever I get stressed, I get diarrhea. It's really good. The only way to solve it is just working. Put it there. So I wanna. What do you wanna study? We wanna do multinomial logit. First of all, we can create data. We can synthesize data. We don't have access to eBay's data set yet, but we have access. We can create our own data. It's definitely better than nothing. And then we can. I need to. I think this time I'm gonna buy a new old phone. Um, this one's charging port is bad. I cannot connect it here. So, okay. And I'm charging it wirelessly. Fuck it! Multinomial logit. How do you call it? Alright, multinomial. I say logit, but can you repeat your answer?
Sure. Could you clarify what you mean by MNL? Are you referring to multinomial logit model, common in economics and machine learning?
Logit, multinomial. Multi. Alright, logit. And all right. Okay, nested multinomial logic, which is related about categories, and we have mixed multinomial logic, which is about um, personalized. So our problem so far, we have two types of users and two categories of products. Let's take a look and see if we can try to make these two ideas friend. So tell me about, so what is multinomial logic? I know that, I already know that. So we have similar to Ursus paper, we have UI of item I equals VI plus epsilon I. You observe VI at the beginning and epsilon I will be observed once you click on it. So it's like how much information will be revealed, something like that. But the thing is that multinomial logic, love it or don't love it, has is for a set of items. It is not for a ranked, ordered set of items. It is for set regardless of their order, which is easy to make it work for an ordered set. We just add a cost regarding to the order, the location of the place. So if item is I for item, UI will be V of I plus epsilon I minus cost of the position or pi of I. That's it, that's simple. And maybe we said pi minus 1. Alright, I don't care. And what else? So, oh, okay. And the users do not maximize utility. Instead, what they do is the probability of buying I or getting click is e to the UI over 1 plus sigma e to the UI. That's it. I think that's MNL, multinomial logic. MNL. Then we have nested multinomial logic and mixed multinomial logic. Let's break down multinomial logic. MNL model, a foundational tool in choice modeling, especially for understanding consumer decision and widely used in assortment planning, making, marketing, transportation, platform ranking, and more. The MNL model describes the probability that a decision maker, consumer. All right. One question I have. I know it's unrelated, but I want to know if there is a self-similarities IFS as semigroups that are generated by iterated function systems like the Sierpinski's triangle or Koch union application of contraction map is not a semigroup under group theory and self-similar groups. All right. Okay. Alright, I'm getting diarrhea, so fuck this. Alright, let's focus on this. And um, I getting a click, and this is it. And I want to say search cost is only about the position. So for each alternative j in the choice set S, the utility to individual I is, so we have, they also added utility of individual and item j, so it's already kind of personalized. Vij epsilon ij, I like it because, oh fuck, I have I know, fuck, now I have to pause this. Alright. Vij deterministic component observable by the researcher based on product feature, prices, etc. What is it in our situation? It is the relatability. That's it. Is a random error of unobserved assumed to follow a Gumbel extreme value type 1 distribution. We can even assume we don't have epsilon I because we don't have it. Alright, why do we need to have it? Choice probability formula is given. Oh, it's even e to the Vij over some of the Vij's. Not, oh yes, because it's the observed part, it is not the non. So it's e to the Vi. I can say minus c. Actually, I want to get the noise 0. What is the point of having noise? Let's remove it. Let's say epsilon I is 0. Common specification of Vij. Dude, I have to go to the restroom now. I'm pretty sure I have to go. So what are we going to do with you guys? I'm gonna pause you. Hopefully I can. Honestly. Okay, multinomial logit. What's going on with multinomial logit? So I want to remove the noise because I don't know what it works for. We have the Vi, probably that's the relatability term. We want to remove it. No, we don't want to remove it. We want to estimate it. Okay, I created a code based on that synthesizes data based on cascade model. We can do one that does the same using, yeah, of course. We can do one that does the same, and can we fix it in a way that makes multiple choices? Actually, this model already lets the user have multiple choices, so I'm not worried about that. Like, the probability of clicking on a subset of item will be just the sum of those probabilities. And yes, and what else? Now it's about, we have two kinds of users. Quite simple, huh? So we have the cost associated to the position. It's only just another way of modeling user click behavior model. The only thing is that the first one, the cascade model, and the second one is this one. And both of them, for example, we have the code, they generate some stuff, and we want to, based on the observed data, we want to estimate the parameters. And there are papers to estimate those parameters. Usually, now common specification, Vij is for user I. That's what we like because it's personalizing. We have two categories, and Vij is Xij. What is Xij? Times beta, where Xij vector of observable attributes, price, brand, star, rating, all the attributes we can observe from a product. So it is modeled finally into an observable. But where is the I part of it? Why Xij has I? I thought it should be Xj times beta I. beta vector of coefficients to be estimated capturing the consumer's preference. Exactly, it should be Vij beta xj beta I. Assumption of MNL independence of irrelevant alternatives. I see, so here is fine because even in our cascade model we are letting users choose multiple products. It's just about clicking. It is early stage of shopping, and you're allowed to do that. You're not buying right away, you're just. And the other one is, okay, the odds of choosing between two items are independent of presence of other options, often unrealistic in practice. Close substitutes should matter more. So if it is unrealistic in practice, why are we doing it? Error terms are IID Gumbel leads to the closed form logic probability formula, but it also causes the IIA problem. What is IIA problem? Where is MNL used? Expedia's hotel search. Well, this is obviously wrong. So, okay, by the way, today morning, ChatGPT helps you get a better understanding, open up the situation, but bullshits a lot. Like, I was thinking, wow, they don't need any PhD students anymore with this shit. This actually is bullshit. ChatGPT just bullshits easily. Ursus paper is not fucking, and it's multinomial logic model. I'm saying just yeah, and it says it in such a confidence way that you believe it is true. Retail assortment, transportation, marketing, recommendation systems. So these are bullshit. Just simple close or fails with closed substitutes. IID, okay, IID is the independent of the can model correlated alternatives or taste heterogeneity extensions of MNL to overcome nested logic relaxes IIA. So products are nested. This category, the other category, groups correlated option, mixed multinomial logic allows preference heterogeneity, assumes random coefficients. That's something we want. Latent class logic allows segment specific preference, discrete clusters of consumers. Maybe that's what we want, latent class logic. 1 to 2 example, consumer $100 hotel with 5-star, $55 hotel. These are the good parts about ChatGPT. I don't know if ChatGPT is right about Vij. So the model is this beta compute beta code version of this. What is a paper that models explains all these models? I don't want to look at ChatGPT because it's fucked up. Like, especially with this Vij equals Xij beta. I feel it should be Xj beta I. Because Xj is about observable of the item. Discrete choice analysis theory and application to travel defined by Moshe Ben Akiva and Stephen R. Lehman. Discrete choice model. Actually, Wikipedia is a good option. MNL. Not multinomial logistic regression, that's something else. Yeah, that's obviously so. What happened to Wikipedia? It looks so ugly. Alright. Alright. Yeah, here it says pi jk. What is pi jk? Choosing among m alternatives in a choice set, let pi jk denote the probability that individual j chooses alternative k. Let xj represent the characteristics of individual j, and let zjk be the characteristic of the case alternative. For example, xj may be an age and ezj travel time. So whatever it says beta k xj. That's what I care about. And so let's fix fucking ChatGPT. Beta shared and beta. So ChatGPT is, you cannot never trust that. It's really good to start, but fucking can fuck you over. okay, he was not that wrong. There is no preference heterogeneity. So why are we using different user size? Oh, okay, to model. Or when you can represent it with covariates. What you wrote, this is mixed logit. Oh, okay, what I wrote is mixed multinomial logit setup where, so okay, ChatGPT was not wrong, but believe me, it is. XJ are and item attribute fixed across individuals, but are individual specific. So MNL is not this. Actually, I don't know why IJ. MNL is VIJ, not VIJ, I want to say VJ. Why are we differentiating between users? Like VI, we are not dealing with data yet. So VJ is XIT beta. XJ, I want to say J. MMNL says VIJ equals XJ beta I, right? And your opinion from that more general and realistic as well. So what is nested MNL? Oh, they add a coefficient or multiplier before the random noise, which I don't like. Because I want to make my noise 0. Powerful general self-test are grouped into subset nests that capture choices and MNL makes strength. And correlation is unobserved utility with alternatives are grouped into nests. So say if you are modeling transportation choices, this one public, second is private, public is bus train, private is car, Uber, for how to travel. This hierarchy allows for correlation between bus and train, for example, mathematical formulation, set of all alternative contains alternative J beta. Uij is Vij plus epsilon ij has correlated this within each nest. Has a scale parameter lambda g. How much correlation exists within that nest? Choice probability. The overall probability of choosing option J is PG times PJG. Choosing nest G is IVG. PG, what is PG? Probability of choosing JG. Okay. Sigma G prime with IVG. Inclusive value, summary of how probability of using J within G is Low correlation handles correlated item. Decision modeling. I still don't have an intuition how it is related to hierarchical decision model. Closed form expression for choice probability. Mixed logic. Wait a second, we have mixed multinomial. Okay, this is the formula for it, but I don't understand. It's complicated. Heterogeneity, like mixed logic. So, okay. Why should we use nested logic or why should we use mixed? And how is the lay? I mean, it seems both of them can be used. What is and the other one was, what was it? Latent class logic. User picks the product with the highest with it, no. Choice probability, it is beta, beta. Wait, why is it this? Then that's it. Oh, okay, that's true. Okay, the outer integral averages all possible beta solutions. Since the integral is not closed form. Actually, I don't want to even estimate it. It's just we have two types of beta, and attributes, and then coefficient. Flexible substitution. Yeah, I think MMNL and nested MNL, like, they can be used instead of each other. No nesting required. Kind of question. I think, yeah, what I like about it is that we can also set epsilon to 0, because I don't know what is the point of epsilon in our study. Yeah, that's true, okay. So what is the other one? Let's also look at the latent. Uh, so our users choose by that or there, and now we want to identify which products belong to each category. Which category? How are we going to do that? Category identification. So can we create our data set using mixed multinomial logic and try to... I actually don't vibe with... Fuck that! Fuck nested multinomial. Let's focus on... I don't vibe with it. Get the fuck out of my face. It's more complex. Okay, what was the name of it? Latent class logic. Then we need to categorize the items. Alright, we categorize the problem with mixed multinomial logic, because at the end of the day we want to do category identification on the products, not the users, right? Let's assume we drive all of the parameters Vij's. So to mixed logic. The problem with mixed logic is that it doesn't tell us which category of products they belong, right? The LCL model assumes that the population is made of a finite number of observed latent segments, unobserved, like our case, two unobserved latent segments, and each segment has its own preference structure. Instead of modeling continuous heterogeneity like mixed logic. Okay, that's what we want. Seems that people fall into a small number of distinct types or classes. This is our case. People fall. Also, we want to say products fall as well. And each class behaves differently. So it's like saying some people are bargaining hunters. I care more about this. Are quality seekers. Bargain hunters, quality seekers care more about this, but you don't observe these groups directly, you infer from... But I don't want to know what people are. I want to know what my product is. Number of latent classes, beta C, coefficient vector for each class, constant over probably each member of the class. I want that. Probability user belongs to class C with weight pi C. Alright, the utility per individual. I choosing alternative belong to C is this. Probability of relevance time probability of what was the other one? Probability of relevance times probability of observability. I don't know. Choice probability for user I, pi C, that's okay. So this is just a discrete case of the other. Oh, okay. Requires choosing number of classes. Model selection becomes important. Interpretation can be messy, especially. We want to do market segment, but we don't want to do consumer segmentation. We want to do product segmentation. So it seems it is responded already. Oh, estimation. Also, it's talking about the estimation, which is super important. Y expectation, maximization, E step, estimate probability each user belong to each class. M step, estimate beta C for each class given those probabilities. Repeat until convergence. Try a code example of fitting latent class model. So, okay. The only question I left here is there a nested logic model that okay, what are the parameters to first of all I wanna know we need to also okay, xj's are not like in the model we assume vj's are deterministic, but to be honest, they are unknown. They're deterministic but unknown because we don't know betas, right? Xj's are known. It is the attributes of products. We know them, their features. Beta is unknown. VJs are unknown. So, if we don't know beta, we don't know Vij as well, right? And no beta, then you don't know another mistake, utility. Here is the logic step by step. What is Vij? It's observable on the order of the user assigns to option J, typically Vij xj. Okay. I don't know beta. Instead, data from observed choice data using maximum likelihood estimation or Bayesian inference. Observe users choosing products over time. They choose what gives them their highest utility. So, for the beta, then Actually, VIJ depends on it. Alright, so what was nested logic? Can we have a nested logic model without the epsilon part? Can I change it to 4? Sorry. Yeah, I cannot. So stupid. Or we can say Vij is 0 and it is lambda g epsilon ij, and this is actually lambda j epsilon ij means xj beta I. And okay, we can actually say we are using mixed multinomial logic, and this feature of attributes, right? What is it? It is price, la 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 la, all of the things that we can see, and it has one extra, which is the category of the item. Extra. And closed form choice, and it is 0 or 1, and we want to find that it's not observable. The nesting structure allows correlating. So okay, actually the goal of nested logic is that closed substitutes aren't treated as fully independent. That's not the, okay, the goal of nested logic is that closed substitutes are not treated for products in the same category are not treated fully dependent. So it is not our study. Actually, nested logic is not our case. If you remove outside, then utility becomes purely deterministic. So the agent always picks the highest value products, and the model becomes rule-based or score maximum, not probabilistic. If you are modeling strategic agents or system. That's bullshit of ChatGPT. If I set the epsilon to 0, that's beautiful. Alternative you could try. That is also what I like. It says alpha of category plus xj beta t. I said add one dimension to beta and xj, which is the same. Yeah, I like that. Want to structure the product by gathering the value within. You can. This is not even O1. This is for O. Gets a base utility alpha c. Version based on its features. This represents the categories. Random utility softmax over categories first, then products. Oh, wait a second. Alright, so let's focus on multinomial logic models. It had some other suggestions as well, which are interesting. Set-based or deterministic whole set ranking, and softmax over categories first and product. Let's focus on this. So I like this model. Vij, epsilon is 0, because I like to keep it simple. Simple. Vij equals alpha j I can say alpha ij if product I and user I in the same category or not, plus xj. Well, xj beta I is the same shit. And then I want to say, how can I find those? How do I what is the estimation rule for algorithm, not rule, for mixed logic model M, and L. I don't know even we need alpha ij, to be honest. The thing is that xj is vector of all the features of the product, and we have two types of beta. Our approach, common estimation method. This is the most popular approach. R samples of beta means users approximate the choice probability. What is theta? By the way, how much time do we have? Okay, and the third method is, one is simulated maximum likelihood, I like it. Second is base mixed, what is it, MCMC, Markov chain, Monte Carlo. EM is less common, yes, the computer expected likelihood given current guess of data, maximize it was. So what is theta in this formula? Beta comes from theta. I didn't know that. Theta is a parameter. What's the time? So what is theta? Let's go. I know there is nothing left in me. I think we are very close. So nested logic model, fuck that. And we have mixed logic model. It's a hyperparameter. It refers to the parameters of the distribution from which the individual distributed level states are drawn. Here is the role of theta in MMNL. In mixed logic, we assume beta I comes from f beta theta, that is into from a distribution parameterized by theta. Dude, I'm for beta parameter theta multivariate normal. For a multivariate normal, beta is the mean and the variance. Log normalness, uniform this mixture of Gaussians, dude, in the estimation process. Estimate. Okay, we also estimate theta. Alright, we have it. Alright, guys. It seems we have it, dude. I really have to go to the restroom again. I don't know. I hope it's a false alarm. PhD is stressful. Guys, it's fine, dude. I think honestly, diarrhea is fine. I mean, it's not even diarrhea at this point. But some people get heart attack. I hope I don't get there. A PhD is not worth it. I believe. I think a PhD is not even worth a diarrhea. That's why I'm studying. I don't like diarrhea, so I study. I also ate a lot of, what is it called? Plums? Or not the plums, but the other one. Apricots. Dried apricots. Maybe that's that. Maybe I'm not even stressed. It's just a placebo effect. Or whatever, some other effect. This is just apricot effect. It's not even psychological, but I am just saying, oh, I got diarrhea, so I'm stressed. I guess that's it. I'm not even looking at myself today. Let's finish it. I think we found something deep and foundational. So we have the mixed multinomial logic, and I'm gonna do it. The thing is that beta xj is the attributes of the product that we can see and it's observed. Beta I is about the personalization of the products from the user. Beta I actually says, we can even assume if I want to say it like that, yeah, beta I is good too. Like even inside within each category, right? Within each category, products have different values, right? So I want to say, like we can say Vij equals Vij tilde, which is within the category, plus alpha ij, but the term alpha ij is like the big number that, for example, we want to add this constraint that e to the alpha ij, for example, is, or alpha ij, so if they match, right? We want to say for each j, which alpha ij is 1, e2 Vij, which is e to the alpha ij plus xjt beta I, is greater than, much greater than e to the, to be honest, this constraint is too much right now. Let's be messy, let's not be exact. Xj for alpha j is 0. I want to say, alright, if you are in the same category, your user and your product are matching categories, their utility is better than any product from the other category. What we can say, for example, like we can say norm of xj's are less than 1, like they are normalized, and norm of beta i's are also normalized. There are only 2 of them, less than 1. And for example, we can say alpha is greater than 10. That's really good, or some big number. And alpha is largely greater than 1, so we can, yeah, that's easy. All right, and you are trying, wait a second. So we are gonna also estimate beta, theta. Beta comes from, for us, and as for us, big A-listers. All right, comes from this distribution F. Sure. Comes from this distribution. Actually, I don't know what is the point of having beta I, some bullshit. I want to do it like this. Vij equals alpha ij plus, for example, beta ij. Alright, it's not a big deal. Alright, then beta is this. I want to say beta ij. I don't want to say even features times. But it's good to have features because it's really closer to data set we will receive. And beta is are known, so xj's are known, so it's not a big difference. But we simply can say beta ij, alpha ij plus beta ij. Alpha ij is the matching factor, and beta ij is a score within each group. Right? So you can have a sorting or relevance inside your item, but your relevance for another non-matching consumer really does not matter. And so the probability of you being chosen is e to the alpha ij plus beta ij minus c of pi j. It doesn't even depend on the consumer, over sigma 1 plus over j e to the I alpha ij beta ij minus c pi j. Alright, that's simple. And we want to find, that's what we want to do. We want to find alpha ij we don't want to find alpha ij. Maybe we can estimate alpha ij, but what is the main goal is finding which products belong with to. So okay, that's actually a good proxy, right? If you can find all these alpha ij's and I say, all right, for consumer 1, alpha 1 1, alpha 1 2, alpha 1 4, and alpha 1 7 are in the like very big, so you can say 1 2 4 7 are in the same category probably, right? Choices probability 1 over r1 r exp x to r. The observed choices as closely as possible. What is the r? What is r? Alright, we are going to, I said theta. What is theta? In mixed lighting, assume theta is coming. This is random drawn. We wanna, okay, it is the characteristic of the noise. For example, even if beta is from even if beta is from normal, okay, we can change this part later. I don't want to spend so much time on it right now. Noise, then we don't want to estimate beta because it is just a realization of from distribution theta, and then we want to estimate theta. In the estimation process, you are trying to estimate theta such that the simulated choices probabilities are this. How do we have Pij hats? It's just how many users. Well, okay, Pij hat is weird, but exactly, Pij hat are independent of j, independent of I, Si. Oh, user I chose all of those threads. Why is this I dependent? What I like about it is this way theta is something we can differentiate. In the previous model, we couldn't differentiate with compared to theta. Is it the same here? We only have the click model. So we can estimate theta. But we don't wanna, okay. So what are the parameters that I want to estimate? Can you list all data we have and everything, all parameters we want to estimate? So I say we want to estimate not beta but theta, and we don't want to xij's, we know them. What else do we have in the model that we want to estimate? But it doesn't say anything about product. But I'd like to estimate beta as well. If I cannot estimate beta, how can I say fucking thing about it? Alright, let's see. What's observed and what's latent parameters in a typical mixed lab? We have individuals, we have available, the alternative actually chosen. We know which are, what are the data they chose. Choice of alternative available to object I. Because an alternative is an I. Extra observable characteristic, which is all. What is the difference of yi and si? Si is choice set of alternative available to individual I. Yi is chosen alternative by individual I. I want to say Si is the same for everybody. Xj, observable characteristic features of user, could also be Xij. No, Xj. Alright, perfect. Unobserved latent variable. Individual preference parameters. Beta, yeah, but so we want to estimate beta i's and theta at the same time. What do you want to infer from data? These are random coefficients representing individual. We do not observe beta I, we assume they come from a distribution. But how can we make them beta I? Like, do we also differentiate with respect to beta I? Hyperparameters, these are the parameters of the distribution. What we estimate using simulated maximum likelihood. If beta I count, then theta is this marginal distribution of beta. Latent class. Okay. Latent individual uses. Okay, so one question. If all users, well, that's not the case. For example, in eBay, we know that different users see different things. But let's keep it simple. If all users see face one ranking, one rank list, does it mean SI is the same, I think. And the other question among users. And the other one is, are we going to estimate beta and its hyper? That will be great. I love it. Theta. That's amazing at the same time. I have to finish it, honestly. If all user face the same rank list is the same. So actually this mixed logic model is more flexible. We can let users face different lists, which is common in tell me, which is common in eBay, because fucking list updates, things come and go. Constant trust user, even though SIA, the individual probability of choice base still varies because so the difference in behavior across users come from different latent spaces, beta I, not from differences in audio. Okay, so do we estimate beta I and theta at the same time? It depends on the estimation method. Simulated maximum likelihood, you do not estimate each individual beta i's, instead you estimate theta, the mean and variance of the distribution beta directly. You simulate many beta i's from that theta to approximate the choice probability, so beta exists conceptually, but you never estimate it. That was what I was thinking. So if you are estimating theta, you do not estimate beta, you just say therefore. But this won't help us. This shit won't help us, because at the end we want to say, alright, these users have this characteristic, and based on users as proxy, we want to find items that do that. Estimate theta and treat beta as an integration variable, exactly. B, hierarchical base MC. Here you do estimate each individual's beta I as latent variable, and you also estimate the hyperparameters theta, the distribution over beta. This is a joint estimation. The posterior of beta I depends on the data and current theta. Data and theta and beta. Theta. The posterior of beta I depends on data and current theta, the posterior beta I. This is common in marketing and panel data setting. Recover individual level heterogeneity. Yeah, we wanna recover individual level heterogeneity. Summary table. Same rank list, same as I. Yes. So to be honest, we don't want hierarchical base. I like that. Let's go. What if we compute theta by max likelihood and then find beta based on that, or use a EM method to switch between theta and beta. Honestly, that's a good idea too, and we can figure it. Now you're asking the kind of to how people actually employ, especially when they want to both aggregate level parameters and individual. Yeah, and yes, but your suggested hundreds are actually used in real application through both options you are thinking of. Estimate data via maximum likelihood and recover beta I. Parameter theta using emulated maximum likelihood. These are just algorithms. They don't need to be perfect. Max of this motherfucker. Once you have this, treat it as known and compute the posterior estimates beta I. Estimate data I by maximum and posterior point. Likely beta posterior. So R, this is coming in play. Does not refine theta once you use EM algorithm expectation. This is closer to how people deal with latent variables in general models. Given the current guess of theta t, compute expected likelihood. M step maximize the expected likelihood over theta. So we have a guess for theta, compute the expected likelihood, and then maximize the expected likelihood over theta based on new theta, iterate and create new beta as this forward. But it doesn't give us the best beta. Our beta is nah, I don't like the EM here. I want to estimate. What if I just assume theta is given and estimate beta? I think that's the one I want to go, or the first one option. Estimate theta y then recover beta I. That maximize the data. Because I need to find beta I or alpha ij, and then all right. Oh, okay, it gave me the formula as well. All right, sounds good. We made a lot of progress. I think we can have the code.